8.1 Average value of a function. Before in Unit 2, we first learned about average rate of change, which is f of b minus f of a over b minus a. However, there's something else that's called the average value, and this is something students often get messed up on, confusing the two. The average value of a function on an interval a to b is 1 over b minus a multiplied by the integral from a to b of the function f of x dx. Its average value is this right here. Average rate of change is is your slope formula. So if you want to find the average value of this function from 6 minus x squared on negative 1 to 3, you do 1 over 3 minus negative 1 multiplied by the integral of 6 minus x squared dx from negative 1 to 3. So this gives you 1/4. That's equal to 1/4. And let's do this integral right here. Integral of 6 is 6x minus x cubed over 3 from negative 1 to 3. And if you plug these in, you solve this, you end up getting an answer of 11 over 3, which is roughly equal to 3.6 on the calculator. So the average value from negative 1 to 3 on this graph is about 3.6, which is right here. That's the average value of the graph. So when does this function assume this value? All you do is set the function equal to 11 over 3. So 11 over 3 is equal to 6 minus x squared. So bring the x squared over. X squared is equal to 6 minus 11 over 3. X squared is equal to 7 over 3. Square root both sides. X is equal to plus or minus square root of 7 over 3. But the interval here is x from negative 1 to 3, so we're only using the positive version. X is equal to square root of 7 over 3, which is roughly 1.527. Question 2. What's the average height during the first 3 seconds here? Average height, so we're going to do h of t is height, so the average height is just 1 over 3 minus 0, because first 3 seconds is from second 0 to second 3. Integral 0 to 3, h of t dt. If you put this into the calculator, 1 over 3 times the integral of 0 to 3 h of t, we're just using x's, you get an answer of 23.5. So we can write that down. All right, this one's a little trickier. B is asking, what is the average velocity during the first 3 seconds? Average velocity. Remember, velocity, so in this case, I'll just show you here. You're using the average rate of change because velocity is the derivative of the function that we're given. So it's h of 3 minus h of 0 over 3 minus 0. And then you put that on the calculator or you do the computations, you get negative 7 feet per second. So if we did this, we would have gotten the same answer, negative 7. Average velocity, it has to be, the integral has to be of the velocity function. So these two here are the same. So question 3, r of x is equal to 2 sine x minus 1, where r is the rate at which Mr. B's waistline is changing. What's the average rate of change that Mr. B's waistline changes from 10th to the 12th month? So if you see average rate of change, you might automatically think, oh, f of b minus f of a, but you have to be careful. This is already the rate. here. So we're doing what we just learned. 1 over 12 minus 10, 10 to 12, r of x dx. And then if you put this one in the calculator, you get about negative 2.683 inches per month. Again, you have to be careful with what the question states and what they're asking. So what's the average rate? What's the average change of this rate? Then this is where you use your typical average rate of change f of b minus f of a because they want the average change of this rate. Whereas in part A, they just wanted the average rate, which it already is. So this is going to be r of 5 minus r of 0 over 5 minus 0. You do that on the calculator, you end up getting about negative 0.383 inches per month squared. Again, this is a lot here. If you have questions, please stop now and ask your teacher. But otherwise, you can start the practice.